Right now, as you watch this screen, a 45-ton ghost is hurtling through the vacuum of space on a collision course with destiny. It isn't a rogue asteroid. It isn't a piece of cosmic space dust. It is a man-made Leviathan, a massive rocket booster abandoned in the dark, tumbling blindly toward the lunar far side. In just a matter of moments, it will strike the surface with the explosive fury of 15,000 sticks of dynamite, blasting a crater 50 feet wide into the ancient crust of the moon. And the most terrifying part? Nobody planned for this to happen. Welcome back to Infinity Baba, my brilliant searchers of truth, science lovers, and cosmic explorers. Today, we are embarking on a harrowing, high-stakes journey into the darkest corner of lunar history. We are tracing a trail of twisted space metal, secret lunar crashes, and dangerous physics that could dictate the fate of human survival on the moon. Stay with me until the very end, because the scientific secret buried inside this upcoming impact isn't just about a lost rocket. It changes everything we thought we knew about the future of human civilization beyond Earth. To understand how a multi-million-dollar piece of space technology became a runaway missile targeting the moon, we have to rewind to January 15th, 2025. Launch Complex 39A at the Kennedy Space Center in Florida. The atmosphere is electric. A giant SpaceX Falcon 9 rocket roars to life, ripping through the atmosphere carrying two highly sophisticated commercial lunar landers bound for the celestial dust. Among them was the historic Blue Ghost lander, built by Firefly Aerospace out of Cedar Park, Texas, a machine that would go on to achieve a flawless lunar touchdown. Riding alongside it was the ambitious Resilience lander, crafted by the Japanese space pioneer iSpace. Once the Falcon 9 lifted these heavy crafts into near-Earth orbit, it was the rocket's 45-foot upper stage that fired its massive engines, hurling the landers out into the deep cosmic void toward the moon. Under normal protocol, once its job is done, a second-stage rocket is supposed to enter a highly elliptical orbit, slowly pulled down by Earth's upper atmosphere to burn up as a harmless meteor shower. But space is never predictable. For reasons that still baffle top space engineers, this massive stage completely missed the atmospheric safety zone. Instead of burning up, it drifted into a gravitational no man's land. Week after week, month after month, for 19 agonizing months, the dead booster looped through the void, its orbit slowly distorted by the complex gravitational tug-of-war between the Earth, the Sun, and the Moon. It became a cosmic phantom, silent, untracked by traditional military radars. But that's only the beginning. What scientists discovered next, hidden deep within routine sky mapping software, sent shockwaves through the astronomical community. Enter Bill Gray. Gray isn't a NASA flight controller sitting in a multi-billion-dollar mission control room. He is the independent astronomer behind Project Pluto, a specialized software project that calculates the trajectories of space objects that the United States military doesn't track. Gray relies on a global network of dedicated amateur astronomers scanning the dark heavens with private telescopes. On April 29, 2026, Gray fed new orbital data points into his system. The algorithm crunched the numbers. And then, the screen spat out a chilling prediction. The rogue Falcon 9 upper stage wasn't just drifting. It was trapped in a terminal gravitational dive. Gray calculated the precise moment of doom, Wednesday, August 5th, at exactly 2:35 a.m. Eastern Time. The impact point? Near the mysterious Einstein crater, sitting right on the far western edge, the limb of the moon. Think about the sheer impossibility of this calculation. A 45-ton cylinder of steel and aluminum floating in thousands of miles of empty, dark vacuum, tracked by a handful of ground-based telescopes, heading toward a precise collision point over 230,000 miles away. When Gray published his findings, space agencies around the world, including NASA and commercial operators, scrambled to verify the data. The math was undeniable.
The crash was absolute. There was zero fuel left, zero steering capability. Nothing on Earth could stop it. What scientists realized next shocked everyone, because this accidental disaster was about to accidentally solve one of the deepest mysteries in planetary science. How could a destructive collision reveal the inner secrets of the moon? To understand why researchers are so eager for this crash, we have to travel back to the dawn of the space race.
Humanity has been putting metal in the moon ever since September 13th, 1959. On that historic day, the Soviet Union's Luna 2 spacecraft completed a treacherous 36-hour translunar trek, executing a planned crash landing between the Sea of Rains and the Sea of Serenity. It was the first human object to touch another world. Since that day, nearly 70 spacecraft and spent booster stages have soft landed, or violently crashed, onto the lunar dirt. During the legendary Apollo missions of the late 1960s and 70s, NASA realized something extraordinary. When the massive Apollo Saturn V rockets hurled astronauts toward the moon, the empty third stage, the S-4B, was no longer needed. Instead of letting them float away into deep space, NASA engineers intentionally targeted those massive rocket stages to slam directly into the lunar surface at terrifying speeds. Why? Because astronaut crews on earlier missions, like Apollo 11 and 12, had placed sensitive seismic instruments, moonquake detectors, on the lunar soil. When a giant rocket stage of a known mass hits the moon at a known speed, it acts like a giant cosmic hammer striking a bell. The resulting shockwave ripples deep through the crust, through the mantle, and back up to the surface sensors. By reading those man-made moonquakes, NASA scientists were able to decode the hidden, layered structure of the moon's interior for the very first time. In fact, during the catastrophic Apollo 13 mission in 1970, while Commander Jim Lovell and his crew were fighting for survival inside a crippled spacecraft, flight controllers successfully targeted their heavy S-4B rocket stage to hit the moon. When Houston confirmed the impact seismic wave to the crew, Lovell famously radioed back, "Well, at least something worked on this flight." But the mystery becomes even stranger, because the upcoming SpaceX crash isn't happening in the Apollo era. It's happening right now, in an era where high-powered telescopes and lunar satellites can watch the destruction unfold in real time. Let's break down the sheer, terrifying physics of what happens when 45 tons of metal hits an airless world at 5,400 miles per hour. A liquid-fueled rocket stage is essentially a hollow metallic shell, a massive, empty fuel tank with high-performance engines bolted to the bottom. Unlike a solid iron asteroid, it lacks mass density. Yet, hitting at speeds 7 times faster than a bullet, density ceases to matter. Kinetic energy takes over completely. Astronomer Bill Gray calculated that the impact will unleash a localized energy blast equivalent to 15,000 sticks of dynamite, roughly 3 tons of pure TNT exploding simultaneously. Imagine the scene on the lunar surface. The silent, ancient dust of the Einstein crater, untouched for billions of years, is suddenly obliterated. The shockwave pulverizes the lunar regolith, melting rock instantly into glass-like beads and blasting a blinding plume of debris miles into the blackness of space. Gray notes that if rocks and pulverized dust are blasted upward at 224 miles per hour, they will climb through the weak lunar gravity for a full minute, reaching a height of nearly 2 miles above the surface before plummeting back down. But here is where top astrophysicists are fiercely divided. While Gray predicts a modest plume, computer modeling published on the astrophysics server Archive tells a dramatically different story. Their advanced simulations suggest an explosive ejecta spike shooting up to 62 miles high, stretching over 114 miles laterally across the horizon. Think about that scale.
a curtain of glowing cosmic dust rising higher than the atmosphere of Earth, standing against the void of space. Could human beings sitting on Earth, looking through simple backyard telescopes, actually witness this historic plume? Because the impact site sits right on the western edge, the limb of the moon, the flash of impact itself might be hidden by curvature. But that colossal plume of dust? It will be thrust out into the pitch-black background of open space. This stark, light-dark contrast gives astronomers on Earth a rare, front-row seat to an extraterrestrial explosion. Every major observatory on the planet, alongside thousands of private stargazers, will have their lenses pointed at the Einstein crater, praying to catch the lingering ghost of the debris cloud. And what happens next completely rewrote what we thought we knew about orbital tracking. High above the moon, drifting in a perpetual polar orbit, is NASA's legendary Lunar Reconnaissance Orbiter, the LRO.
Since 2009, this high-tech NASA satellite has been mapping every square meter of the moon with breathtaking precision. It has photographed the abandoned Apollo lunar buggies, the flags, and the boot prints left behind by astronauts. The LRO won't be directly overhead during the exact second of the crash, but space geometry is on our side. The orbiter swept over the Einstein crater on July 29th, capturing pristine before imagery of the undisturbed soil. On August 12th, just days after the collision, LRO's high-resolution cameras will sweep over the exact same spot again. By comparing these two images pixel by pixel, NASA scientists like Dr. Brent Gary will spot the brand new scar, a fresh crater expected to span more than 50 feet across. By measuring the exact depth, rim height, and debris distribution of this crater, NASA doesn't just get a cool picture. They get hard, physical data on gravitational physics and soil density that no supercomputer on Earth can simulate. Which brings us to an urgent, high-stakes question that NASA, China, and private space companies are desperately trying to answer. What does this mean for the future astronauts living on the moon? We are standing on the precipice of a new golden age of space exploration. Under NASA's Artemis program, the USA and its international partners plan to land humans back on the moon and build permanent habitats. Simultaneously, China and Russia are actively advancing their own lunar research stations near the South Pole. Uncrewed cargo landers, commercial resupply missions, and deep space rocket stages will soon flood the Earth-Moon transit corridor. Now, imagine a scenario just 10 years from today. A permanent lunar base is operational. Astronauts are inside pressurized modules, growing food, extracting ice, and conducting solar research. Hundreds of miles away, an uncrewed rogue rocket stage, abandoned after a commercial delivery, slams into the moon at 5,000 miles per hour. On Earth, an explosion miles away is stopped by atmospheric drag. On the moon, there is no atmosphere. There are no air molecules to slow down flying shrapnel. A tiny pebble blasted out of an impact site can travel completely unhindered for dozens or even hundreds of miles across the landscape at bullet-like speeds. If a microscopic piece of ejected lunar rock hits an inflatable astronaut habitat or an unshielded fuel depot, the consequences would be catastrophic. Analyzing the scale of the SpaceX Falcon 9 blast and mapping its debris zone isn't just an academic exercise, it is an absolute survival requirement for NASA safety protocols. Scientists must calculate the absolute minimum safe distance human explorers must maintain from unmonitored impact zones. How far is far enough when the sky itself offers no protection? The answer is far more surprising than you think. The moon has been humanity's cosmic mirror for millions of years. For ages, it sat pristine, untouched, silent, a fossilized memory of the early solar system. Today, it is rapidly becoming a celestial graveyard of human ambition. From the wreckage of Luna 2 to the crashed stages of Apollo, from the heroic resting spots of commercial landers like iSpace's Resilience to this incoming SpaceX booster, our planetary footprint is expanding across the cosmos. Every scar we leave on the lunar dirt tells a story of human risk, unexpected failure, and brilliant engineering triumphs. Rocket scientists have been skeet shooting the moon for over 67 years. And as humanity prepares to establish a permanent presence across the solar system, our punch-drunk nearest neighbor will inevitably take more beatings. Each rocket that hits the lunar dust carries a piece of our history, a fragment of our intelligence, and a silent warning about the sheer power of gravity. We are no longer just visitors in the night sky. We are terraforming the cosmos with our artifacts. As that rogue SpaceX booster takes its final, violent bow against the far side of the moon, it leaves behind more than just a 50-foot crater in the dust. It leaves us with a profound reminder that space exploration is raw, unpredictable, and breathtakingly fragile. The cosmic dance between Earth and the moon is filled with hidden dangers, physics-defying impacts, and endless secrets waiting to be uncovered. If you enjoyed exploring the mysteries of our universe with us, don't forget to like, subscribe, and turn on the notification bell so you never miss our next journey into science, technology, and space. Until next time, keep looking up, keep asking questions, and keep exploring. This is Infinity Baba.